All right, everybody, I am putting together this factoring review video that I promised you I would put if you are having difficulties with factoring or you just never learned it quite, and you need a little bit of extra support, let's say, then hopefully this will help you. So there are a few things that you can do with different kinds of factoring. I'm going to do a couple of examples of different ones that I think you should know how to do. So one is difference of squares. So this is a specific type of factoring. It's called difference of squares. And whenever you see it, you will know because things look like these things look like a squared plus b squared. I'm sorry, a squared minus b squared, because it's got to be a minus because it's the difference. So the first term is something squared, the second term is something squared. So I've got some examples of those. I'm just going to throw them up here. And one looks like c squared minus 49d squared. Okay. So whenever I do these in my head, I look at these and I say, okay, this is my first term. Okay. Is something being squared there? Yes, the c is being squared there, right? Minus, this is my second term, is something being squared there. Now this is a little more complicated because it's got a number part and the variable part. So I say, well, 49 is a perfect square, that's 7. And the d is being squared, right? So what we see here is I've got 7d, the whole thing is being squared. So if you wanted to, you could say that 7d times 7d, which is 49d squared. Sure enough, it is, right? So the thing being squared here is 7d. If you want to, you can rearrange this just slightly. You can say, look, the first term is the c squared minus the second term is the 7d squared, okay? If you can do that in your head, then okay, but it's important to know what's the first thing being squared and what's the second thing being squared, okay? If you need to take it off to the side like I did right here and kind of work on it on the side, do a little scratch work, then go ahead and do that, that's fine, okay? So the thing about differences of squares, they always factor. Shouldn't have put that right there. Okay, I'm going to put it right here. A squared minus b squared always factors a plus b times a minus b. Okay, this is your little, make a big asterisk on this or something. Star that out. Okay, this is the format that they came in. So we know what that looks like. And then we know it always factors this a plus b times this a minus b. So that's why I need to know what's the first thing being squared. Here it's a c. So I can go directly into my parentheses because the first thing is always the first thing that's being squared. And you see it at the front of both of those sets of parentheses. So this is going to be a c and a c. Okay. And the last thing is always whatever was being squared second, okay? There's going to be a plus and a minus because those are set in the format here, plus and a minus. And then what's being squared the second time, okay? That's why I rearranged this. So we could say that's 7d, okay? So this is going to be c plus 7d times c minus 7d, okay? And if you're not sure, go ahead and think about this. If I multiplied this guy back out, a times a would give me the a squared. Okay, I'm good there. I got you. A times negative b is negative ab. A times positive b is positive ab. So a negative ab and a positive ab, let me write that out, a squared plus ab minus ab. And then I've got, those are going to go away, right? Those will reduce. They're opposite operations. And then I've got the b times the negative b. So it's minus b squared. So we end up where we started from, right? If we multiply it back out, a squared, that stuff goes away, minus b squared. A squared minus b squared, that's what I started with. Check. Okay. So these particular things are always going to factor in the same way. So I've got another example. Okay. Number 2. for these difference of square guys. Okay, these difference of square guys. Again, we're gonna work on it and make sure we always have the fact whatever is being multiplied squared here by itself. Okay, so this one I've got is 144x squared minus 25y squared. Okay, it's getting a little more complicated, right? Maybe I need to go off to the side. So this guy, the first term, my a that is being squared here, if I want to go back to this format we had before, I've got something times itself gives me 144. Well, the square root of 144 is 12, right? So you can double check. 12 times 12 gives you 144. And then we know that x is being squared. So the a here is going to be 12x, and the b here is in this term. And again, we look at it. What is being multiplied by itself to give me 25? Well, it's 5 times 5 gives me 25, right? And then the y is also squared. So it's a little more complicated because the a has a number and a variable, and the b has a number and a variable. But once I've identified what's being squared at the beginning of each of these, I can go straight for the parentheses. And I can say, what goes at the beginning? Well, it's the first guy, whatever is being squared. I'm sorry. Let me rewrite this just so we can see it. Ah, stinker. It's 12x squared minus 5y squared, right? That's the equivalency for this. So again, we're just going to work with whatever it is that's being squared, okay? So here is going to be 12x and 12x. That was the first term, so these guys have to go first, okay? And then remember, in the format that we're working with, it's a plus b times a minus b. There's going to be a plus and there's going to be a minus. And then I say, hey, what was being squared to give me that last guy? Well, what was being squared? 5y, right? So it's the b, 5y and 5y. And they always look the same, right? Inside of the parentheses is AB, AB. The only difference is the sign in between them. There's a plus or a minus. Here I've got C and 7D, C and 7D. The difference is the plus or the minus. 12x and 5y, 12x and 5y, but one's a plus and one's a minus. So they always factor out the same way. All right, so I can definitely tell what's going on in there. Third one of these, and then I will post a factoring worksheet, and if you want to work on it, you can play with it and see if you come up with the same kind of stuff that I do, okay? So the third one I've got is 121 d squared minus 4. Okay, 121 d squared minus 4, okay? So if you want to do this in between step, figure out what's being squared minus what's being squared. So I'm going to let you just work on it and see how you do. Okay, so if you need to pause so that you can work on it a little bit, do that. I'm going to go ahead and run through this real quickly. So I think that 11 times 11 will give me 121, and d times d will give me d squared. Okay, so my first term here, I think, is 11d. So this is 11d squared minus something squared. And what is it that I have to multiply by itself to get me to that 4? And in my head, I'm hearing 2 squared, right? So my b is a 2, so that goes right here. Okay, so 11d is being squared and 2 is being squared. Okay, this is different, definitely a difference of 2 squares. So when I look at it, I say, okay, go straight for your parentheses. There's going to be something plus something, and there's going to be something minus something, right? Okay, I'll fill in those blanks. The first guy came, 121d squared came from 11d being squared, right? So at the front of each of these, it's going to be 11d. One's a plus, one's a minus. And the second guy that's being squared here is the 2. So 2 squared is 4, So at the back, it's a 2 and a 2. 11D plus 2, 11D minus 2. There you go. Okay, so this was this guy's answer. This is this guy's answer. All right. So hopefully that helps you when it comes to difference of squares and we can see what's going on there, right? And then sometimes you might see some, so I'm going to kind of skip out of the difference of squares part. Sometimes you might see some that just have a greatest common factor that you can divide out before you do anything else. Okay, so for instance, this is a continuation maybe of what we just did with the difference of squares, but I'm going to show you one of those. So my fourth example here, I've got 16 e squared minus 4 d squared. Okay. And you can look at that and you can say, oh, that is definitely a difference of squares. But I also look at it and I say, but wait, 16 is divisible by 4, right? And 4 is divisible by 4. So I can pull a greatest common factor. Greatest common factor is the number that will divide evenly into all your terms. Okay, and it's supposed to be the biggest number. Okay, so sometimes when we go to do GCF, we actually don't pull the greatest one. We just pull a common factor. That's okay, but hopefully we can get the biggest one. For instance, 16 and 4 are both also divisible by 2, right? But I know that that's not the biggest one. There's a 4 that we'll pull out. So 4 times 4e squared minus d squared. Now, did you have to do it like this? No, you could wait till the end to divide that 4 out, but I like to do it like this, pull the greatest common factor out first, because that allows me to work with smaller numbers inside of here. Okay, so you just can't forget that that 4 is going to hang around outside. Okay, so I put him down 4 times, and then I go straight for my parentheses. Hopefully we can do this one, but if not, let me do it over here just in case. What's my A? What's being multiplied by itself here? 2 times 2 gives me 4, right? So it's a 2. And E times E gives me E squared. So the A is a 2E. And then the B guy here, what's being squared to give me D squared? It's just a D, right? So if you can set that up and figure it out, then remember that these guys factor something plus something, something minus something, where the first thing is whatever was squared to give me the first term. So the 2e goes at front. Now you cannot, the only thing you got to be really, really careful with difference of squares is if I started with the 4e squared, then I need to start with the 2e. They need to go in the same basic position that the 4e squared was from, because it's the d squared that has the negative, right? And we all know that the negative does make a difference. So I need it to be on the d squared, not on the 2e. Okay. So, and then the last thing that was being squared, it was d times d gave me d squared, right? So I'm going to stick a d right there. So that's it. So sometimes if you factor out that greatest common factor first, I've got smaller numbers to deal with. It's smaller numbers for me to deal with a 4 here and a 1 here than it was if I started from the beginning, 16 and 4, trying to factor those things out as differences of squares. Okay. And then the second thing, and there's lots of different special cases that come in, but I'm not going to deal with special cases. I am going to deal with the AC method. So that's the second method that you really need to know. If you can shortcut this and skip the AC method because you can do trial and error and you know how to do that and you're good with it, then great, no problem. Okay. But sometimes we're not going to be able to do trial and error type stuff. Sometimes the numbers look weird. Like I'm going to give you one right here. Number 5, 6x squared minus 19x minus 7. Okay, on the worksheet that I'm going to hand you guys or let you guys see, This is actually the first problem in there, but it's my 5th example for today. Okay, so when I look at that one, I think, oh my gosh, 19 is a big number, okay, and it's prime. 7 is a prime number, and I've got a 6 out in the front. And a 6 out in the front makes this really ugly, right? Okay, so because it could be when I go for the parentheses, I can't just go straight to the parentheses here. If I went into the parentheses, I don't know. Is it a 1 and a 6? Is it a 2 and a 3? Should it be the 3 and then the 2? Should it be the 6 and then the 1? So there's lots of different options. So I'm going to use the actual AC method. So remember that these all come from the format when I'm looking at a quadratic. AX squared plus BX plus C, right? That's the general form for quadratics that I'm looking at. So here, my A is a 6, my B is a -19, and my C is a -7. And I think if you are trying to do this and you're not sure how to factor, that it is worth the time for you to take just that long. It didn't take me but just a couple of seconds to write that out so that I can see exactly what is going on, okay? So remember the AC method. I think we've already talked about it this semester, but just in case. AC is A times C. Well, that's 6 times -7, right? So that is going to be AC is -42, okay? So we have to figure out what is AC. All right. And basically it is a factor, or it's a function of the fact that I need to eventually multiply these two things together, right? Eventually I'll be in parentheses times parentheses, and I'm going to need to know what thing give me a 42 when I multiply them out. Okay. So when I go to do that, I'm going to say, okay, so I've got -42, and I'm going to figure out what the factors of them are, factors of -42, okay? And I like to do this kind of like a T-chart type thing, just so we can see what all's going on in here. So we know it could be plus or minus on any of these, right? But I'm just going to say, okay, 1 and 42, okay? And then I'm going to say, well, 42 is divisible by 2, so that's 21. And then I'm going to use my little divisibility rule. 4 plus 2 is 6. 6 is divisible by 3. So therefore 42 is divisible by 3. So 3 goes into 42. Let's see, that'll be 14 times. Okay. 14 times. And then I'm just listing the factors right now. We'll deal with positives and negatives in a minute. 3 and 14. And then 42 is not divisible by 40. By 4. I know that because 40 is, and it's really close. So it's not divisible by 4. It's not divisible by 5 because it doesn't end in a 0 or a 5. It is divisible by 6, and I know that because it was divisible by 2 and it was divisible by 3. That means it's divisible by 6. And we happen to know, well, yeah, of course it is. We multiplied 6 times 7, right? Okay. And then I look at these and I go, oh, look, 6 times 7, those are really close together. They're only 1 unit apart. So my other factors would be like 7 times 6, and then 14 times 3, and then 21 times 2, and 42 times 1. So I don't have to repeat those because I know that that's what they are. Okay. All right. So those are all my factors. And then I got to deal with the pluses and the minuses, right? So the problem is what we're going to end up doing, you remember, is we're going to end up rewriting this so that my middle term is split into 2 terms, basically. So this is going to be 6x squared plus something minus 7, right? So instead of 3 terms, I'm going to end up with 4 terms so that I can end up factoring this guy by grouping. So what we're saying is this middle term, if this guy will factor, I should be able to rearrange this thing into the sum of 2 different terms here. So what I'm looking for is these factors that will add up to give me the number in the middle, the B, which is a -19, right? B was -19, okay? So I need, let me write that. I need factors of negative 42. That was my A times my C. That will add up to be the B, which is negative 19 in this case. Okay. That is how I know what I'm doing here. Okay. And the fact that they're going to add up to give me a negative number means that then when I remember, these are going to be a positive and a negative. I know that because the last number is a negative. So it had to be a positive times a negative gives me a negative. So one's a positive and one's a negative. And when I look at this, I say, oh, but whenever I add a positive and a negative, I end up actually subtracting the numbers and taking the sign of the bigger guy, right? So whenever I look at this guy right here, I think, oh my goodness, I need the bigger number to be negative because we take the sign of the bigger guy. So these on the right-hand side were my bigger guys. These on the left-hand side are going to be positives, okay? So negatives on the bigger numbers and positives on the smaller numbers. So then we say, if I add those, do I get negative 19? Well, look here. If I were to add 1 and negative 42, I would get a negative 41, right? Okay, that is not 19, so that's not it, okay? But if I were to add 2, positive 2 plus my negative 21, I would get a negative 19, okay? That is going to be the one I want, right? Because that's the negative 19. But I'm going to just keep on going just a little bit longer. 3 plus negative 14, that would be a negative 11. And 6 plus negative 7, that would be a negative 1. And these guys are not the answers that I want, right? I want the negative 19. So if this factors, there's only one set of factors that will replace this, okay? So, and remember that the middle term has an X at the back of it. So in order for these to be equivalent, I need to put in 2X and negative 21X, right? Is 2X plus negative 21X, is that going to add up to negative 19X? Yes. Okay. So if I pick my correct set of factors, then I should be able to substitute that guy out and I will be okay. All right. So then what? Well, then I just group these, right? Factor by grouping. So grab these two, and figure out what each of those groups has in common. So right here, I'm looking and I'm just ignore these guys back here. We don't care about them for right now. I'm looking at the 6x squared and the 2x and I see, okay, 2x times, if I pulled a 2 out of the 6, that's a 3. And if I divided x squared, divide by x to factor that out in the front, that's an x. Check yourself. Is 2x times 3x 6x squared? Yes. Okay. And then what about here? I divided out the 2x in the front. I factored it out. So what's left over? There's got to be a placeholder. It's not a 0, right? 2x divided by 2x is 1. There's a 1 left over, right? All right, then go to the second set. Normally, if the first term is negative, we will definitely factor out a negative, okay? And it works out really good here because they're both negative. So negative, I think a 7 will come out of both of those, right? Okay. Well, what's left over if I divide out negative 7 here? Negative 21 divided by negative 7, positive 3. Okay, and then that x comes along for the right. Check yourself. Is negative 7 times 3x going to give me back the negative 21x? Yes. Okay. And then again, what should be back here? It was negative 7 divided by negative 7. There's got to be a placeholder plus 1, right? And I can kind of a little bit cheat because I already know what the first thing is that I factored out. So these guys need to match, right? If I can factor by grouping, then these two things in parentheses have to be the same because they're going to end up being the common factor from this big first term and this big second term. Okay, so then I say, what do they have in common? 3x plus 1, pull that out in front. And then if I divide this 3x plus 1 out, what was left over here? Just the 2x. And if I divided this 3x plus 1 out, what's left over here? Just the -7, right? So there it is. 3x plus 1 times 2x minus 7. All right. So that's the AC method. And I know that that is probably where we struggle. So in this particular worksheet, I've got like 21 examples where you can use the AC method to get to where you want to go. Okay. So I'm going to do one more like this. And then I'm just going to set you free with the worksheet, right? So you can do it on your own. All right. This one looks like 4x squared. What number am I up to? 6. 4x squared minus 13x plus 10. Okay. So very similar process going on here. I need my A. A is a 4. I need my B. B is a -13. I need my C. C is a 10. Okay. And then I have to figure out what's A times C. Well, that's 4 times 10. That's a 40, right? Okay. And then I'm going to list out all the factors. So I'm going to go a little faster this time than I did that first time. I'm going to list out all the factors, okay, of 40. And like I said, just list them out. Who cares? And I tend to do the smaller number first and then the bigger number. So 1 and 40, 2 and 20, 3 doesn't go into 40, 4 does, 4 times 10. We know that's actually how we got here, okay? 5 will go into 40, it's 5 times 8, right? 6 does not, and 7 does not. And again, when you start seeing that these are really close together, the 5 and the 8, then we start saying, okay, there's not a lot of other options in there, right? 6 and 7 don't work. So I could do 8 times 5, 10 times 4, and so on. But I've already got those in there, okay? Now let's pay really close attention to these signs, okay? 2 things multiply together for a negative. I'm sorry, a positive. Okay. So we know that could be plus plus, except that 2 things add to give me a negative, right? Whatever these 2 factors are that I'm going to end up with. They multiply to give me a positive, but they add to give me a negative. Well, so for a positive, it's plus times plus, right? Or negative times negative. We know a negative times a negative is a positive. Well, can a positive times a positive, if I get those 2 numbers and make them positive, can they add up to give me a negative? No, the answer is no, that can't happen, right? So what I know is that no matter what I'm doing here, both of my numbers in my factor pair are going to be negative. So negative, 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 negative. Okay, so no matter which one I pick, they're going to be negative. Okay, because they have to multiply together to give me a positive, but they have to add together to give me a negative, right? Okay, so I'm going to, that information done, I'm going to bring this down so I can see it again. Okay, 4x squared minus 13x plus 10, just so we can see it again. Okay, and remind me what we're doing here in your head. Hopefully you're thinking, okay, they multiply together to give me 40, but they add to give me negative 13 because we're going to split this guy, right? It's going to look like 4x squared plus something plus 10, right? Okay, so I'm going to separate this out and I'm going to rewrite it with 2 different terms instead of just the 1 term. Okay, so as I'm looking, when they're both the same sign, I just add. So -1 plus -40, that's a -41. That's not it. -2 plus a -20, that's a -22. -4 plus a -10, that's a -14. We're getting close, but not quite. Okay, so hopefully this one works. -5 and -8, yep, that's -13. Okay, this is the pair I need, right? That's the pair I need. Okay, So that means I'm just going to add an X at the back of both of these, right? This is going to turn into minus 5X and minus 8X, right? Instead of negative 13X. And then I've got this guy rewritten as 4 terms. Now it turns into the same thing we did before. We're going to factor by grouping, grab those first 2, put them in a group, grab those second 2, put them in a group. What's in common here between these first 2 terms? Ignore the last 2. We don't care about them right now. They only have an X in common, right? That's what I'm hearing in my head. When I factor an X out here, that's 4X. And this is going to be a minus 5, right? Because factor out the X, I'm left with the negative 5. Okay, good, good. And then here, like I said before, normally when we lead with an X in there, we're going to, a negative in that first term, we're going to divide out the negative. And I see, hey, they're both divisible by 2. So negative 2 times this guy, when I divide out a negative 2, I get a positive 4X. And this guy, when I divide out a negative 2, careful, he's a positive. It's going to make it a negative 5. Okay. And again, we can kind of take our lead by looking at this first parentheses we had. They need to match, right? They need to be twins. That's what I was told once upon a time. They're twins, they match. Okay. If they don't match, we've either done something wrong or this guy will not factor. Okay. But we have them match. So I'm going to pull the match guy, whatever that term is, out in front. I pull it out of here and I pull it out of here. Now they're divided out in front. They're factored. And what's left over? Well, in this first term, there's an X left over. And in this second term, there's a minus 2 left over. So there you go. Okay. And then these things can get more complicated. If you had an AC, a trinomial like this, and you went, oh, they're all divisible by the same constant number, pull that out first, right? Go ahead and do your greatest common factor first. That gives you smaller numbers to do all this AC stuff with, okay? So hopefully that makes more sense and it'll get you on the right path. So I'm hoping that this works for you and all is good. If you have any questions, let me know. Otherwise, I will assume everybody's going to be good on factoring. All right. Take care. Work on the problems I'm going to send. All right. Bye.